Sequences and summation notation, part 4. Sigma notation. Sigma is the symbol here. We have a variable that we use with sigma notation. Common variables are I, J, or K. These are going to be called indexes. So we might see the sum as J goes from. We have a start, and then we have a stop. So maybe J is going to go from 1 to 5. And then in here, we'll have a formula that uses J, in which we calculate the terms of a series. A sequence is a listing of numbers. A series is adding those all together. And so this might be J squared plus 2. Okay, so we start with J equals 1 squared plus 2. Then we go J is 2, so that would be 2 squared plus 2. J is 3, and we'll continue on generating the terms of the series. And then this symbol here means add those all together. Let's look at an example. Here for problem 48, we have the sum of, okay, so this is the sum of k squared. K starts at 1, k stops at 4. So we have 1 squared plus 2 squared plus 3 squared plus 4 squared. That's going to be 1, 4, 9, 16. Adding all those together, 10, 21 plus 4 will give us a 25. So this is the sum of k squared. The sum of k squared, k starting from 1 to 4. Okay, J is going to start at 5 and end at 15. J starting at 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then we add all those together. Okay, so J starts out at 5. So we have 5 squared plus 1, that would give us 26. Then J goes to 6, so we have 6 squared, which is 36. 36 plus 1 would be 37. Then J goes to 7. 7 squared is 49. Plus 1 would be 50. J next is 8. 8 squared is 64. Plus 1 is 65. J goes to 9. Squared is 81. 81 plus 1 would give us 82. Then J goes to 10. 10 squared is 100 plus 1. J goes to 11. 121 plus 1. J goes to 12. So that would be 144 plus 1. J goes to, that's a 12. 13. 169 plus 1 would be 170. Okay, so that's J equal 13. Almost there. J equal 14 and J equal 15 are our last two terms. If we take 14 squared, 14 squared becomes 196, so that would be 197. 15 squared is 225, so that would be 226. And then we have to add all that together. Our calculator is going to help us do that much better. So we have the sum of a sequence. Second list ops. Second list ops. Sequence, what's our formula? 1 divided by J squared plus 1. We want to go from 5, that's our start, to 15, that's our stop. Step is just 1, which is the default. We don't have to put anything in step. Hit paste. Now these are the terms. Now we want to add those all together. So list, ops, math, sum. We want to sum the sequence. If it can, we're going to get our answer in a fraction. If it can't, then we'll just settle for a decimal. Okay, so if I let J go from 5 to 15, found all the terms of the sequence, added them all together, we would end up with 0.153 to 3 decimal places. Okay, here we would let k equal 1, so that would be 3 times 1 plus 4, which is 7. We would let k equal 2, so that would be 6 plus 4, which is 10. K is 3, 9 plus 4 would be 13. K is 4, 12 plus 4 would give us 16. And then we would end up with k equaling 100. So that would be 300 plus 4. That would be 304. And now I got to add all that up. Okay, something we wouldn't want to do by hand because that's a lot of terms. Let's use our calculator. We're going to go into list. We're going to go over to math. Option 5 is sum. We're going to go into list, go over to ops. We want to sum a sequence. Okay, so our formula is 3k plus 4. Variable used was x. Our start is 1. Our stop is 100. We'll close out the parenthesis for the sequence command. That was done for us. We'll close the parenthesis for the sum command and add all this up. And we end up with 15,550. We always want to know how to set things up by hand. But as the problems get more and more complex, then we want to be able to use our calculator to do those calculations. Okay, here's our last 2 problems, and if you need some extra guidance on step commands, here they are.